Okay, my 1 Act folks, today's Monday, because you're going to be gone tomorrow as well, we're filling in the 5th and 6th row on our formula sheet. These should be the last 2 rows across, and this is the formula sheet you get to use on your test, but here's the deal. When you get to the test, the hardest part, are you guys all listening? The hardest part when you get to the test is like, which row do I use? Like, what the heck am I doing? Okay, so what's the difference between like the binomial formula and like Poisson distribution? Like binomial uses these 4 things: your total number, the number you're choosing, your probability of success, and probability of failure. Like, how do I know I'm using that formula versus this one? Maybe we should write the formula down and then it will help. Do you remember the Poisson distribution? P of x equals mu to the x power times e to the negative mu all over x factorial. I believe that is right. I believe that is right.
You know or you believe?
I believe that is right.
Okay.
Maybe I should look. Un momento, por favor.
I was looking at that.
Hold on. Yep, it's times. There it is. Yep. Okay, we're good. That's why I give you a formula sheet. So, what are the 2 things you need?
Hold on. You need mu and...
You need mu, which is the average, and you need x, and that's it. So, how do you know that you're using the binomial formula and not the Poisson formula?
We have less things.
Yeah, you have less things. The binomial will give you a total number. The Poisson won't. They'll say, like, what's the chances of having 5 hurricanes? Well, we don't know. We don't have an upper limit. We could have 1 million hurricanes. Versus binomial will say, what's the chances that, 5 out of the 7 classes do this or whatever, right? Okay. So you'll have different variables. So look at what you have, and that will help you decide which equation to go with. Okay. So what is mu, by the way? The average, right? So sometimes you will have to calculate the average, like over here in this example, which I'll zoom in on here in a second. You have to calculate it.
Wait,
so mu is the average, mu is the mean. What is x? What do they call it sometimes?
R.
R. Actually, we call it R. What is x or r? Like the number that we're choosing, right? Or like the number that we're interested in. Okay, so that's our information that we need for Poisson. What?
Or is it 15? 45?
Okay, so here's our example. They should have hopefully this written down, because yeah, I made them write this down before I started recording. Do you guys all have this written down? Example. Okay, there are 120 students in 4 classes in a year. Average is, how do I find it?
4.
Average number of students per class.
4.
No. There are 120 students in 4 classes.
Divide.
Yeah. So that means how many students per class? 120 divided by 4 is 30. 30 students per class, right? Find the probability that there are 45 students in class next year. If I have 30 as my average, high chances, low chances, I'm going to have 45.
Not too high, but kind of.
I'm going to, like high chances.
15.
It's a low chance it'll be 45.
Low chance.
Yeah, it's going to be it's going to be highly significant, but it's going to be low chance, right? It's going to probably not happen very often, right? 45 students in a class if my average was 30, right? Because you got to think, if my average is 30, we might have some classes that have 25 and some classes that have 35, right? But 45 students in one class, that's going to be a big, huge class, which we have some of, like in this school, like compared to the junior and senior class. I think the 7th and 8th grade classes are huge, aren't they? I don't know. Sophomore class is big, yeah. So there's that. What is R or X? What's X?
45.
45. Yeah, so let's do the probability. Find the probability of having 45 if the average is 30. We do mu, 30 to the 45 power, which looks kind of weird, times e to the negative mu, which is negative 30, all over 45 factorial. If you screw this up, you will either
It is not.
put the numbers in the wrong spot, or you will type this in wrong. This is pretty straightforward of a problem. It's not that hard. But if you screw up, you will do one of those two things. You'll put the numbers in the wrong spot, or you will type it in wrong. Okay? So, on that note, I would practice typing this in. Find the probability of having 45. Find the probability of having 45.
Is the cricket in here?
Mhm.
No. Not in here.
Yeah, yes, he's over there in the corner. I shoved him all the way over so they could vacuum. Yeah.
Do you have any,
Somebody get this?
do you have any permanent vinyl in here?
What color?
White and black?
Yeah, I have white. I don't know if I have black. Oh yeah, I have black.
That's a relic. You're a relic.
Relish.
No, I said relic, not relish. Need a toothpick.
Do you guys know where your E button is on your calculator?
Yeah.
Oh gosh, I did that wrong.
Oh. Good, Grace?
You got an answer? Yeah. Math. Did you get 0.0023? Yeah. 0.0023, which is 0.2% chance of that happening.
Low.
Significant.
Significantly rare, right? Okay, so significant? Question mark? Yes, if I have 45 students in a class, given that the average was 30, that's a significant change, right? That's significant. Okay, that's not that hard of a thing going across. Okay, mean variance standard deviation. For Poisson distribution, mean variance standard deviation is super easy,
Well,
or should be super
we
easy.
ate most of them now. Like a
What?
third of them at
Let me see how
least.
many
Standard deviation
I can't believe you ate that many.
I know, bro. He literally walked away.
is the square root of mu. Do we remember this?
His name is Alan.
Standard deviation is the square root of mu.
See? So,
Okay. How do you find mu, by the way?
You take n times p.
That's if you're doing binomial.
Okay, you find the
When
average.
you add 'em up,
I
you
think
divide
I just,
them.
when I erased this, it said this.
Yeah.
Some.
Like the sum of them divided by n, that would be like the sum of all the students, 120 divided by the number of classes that I have. Whatever. You're just finding the average, right? The sum of all of them divided by n, okay? How do I find variance? That's like s squared. Actually, I should write them out as sigma, not s. Right? Don't we use sigma for variance and standard deviation?
Sigma, but we already
Okay,
wrote
sigma squared and sigma. You could write s equals sigma or sigma equals s, whichever. It didn't matter.
I use Sigma a lot.
Wait,
So-
wait.
How do you find variance?
To find the mean, you use that u thing.
The mean is mu. Mean is mu, variance is sigma squared, standard deviation is
Sigma.
sigma or s.
Okay.
Okay? So how do I find sigma squared?
Take the square root.
That's just it's.
If the standard deviation is the square root of the mean,
Oh, so it's just the
mean.
mean.
it's just the mean. Didn't we find that that was a weird thing on 5.3? Yeah, that standard deviation or that variance and mean were the same number?
That's crazy.
Yep. Okay, so let's do that for this problem. For this information, oh, I already gave you the formulas and stuff, okay? For that problem, we said that the average was 30, right? That means the standard deviation, or the variance is
Huh?
how much? If the average is 30 from that problem up above, right?
Oh, it's
That means
30.
variance is
30.
also 30. That means the standard deviation is the square root of 30, which is, I don't know how much.
Or like point.
No.
Well, I'm gonna have a number, but I gotta figure out the point. 6?
5.48.
Oh, not quite.
5.48. Okay, there are two ways of determining whether something is a significant event. First of all, if it's less than 5%, like it is here, then it's considered significant. Or, if I have the average and the standard deviation, I can do this. And what number goes in the middle?
Oh.
Average.
30, which is the average, yep. And then I add it, how many times? Twice. I add the standard deviation. I add 5.48, and I add 5.48, and that is 10.96. So 40.96 would be considered significant, right? 40.96. If I subtract 10.96, oh gosh, that is, help me here, 19.04. Is that true?
Yeah.
Okay. Subtract 5.48. Do you know how I got these numbers?
Yep.
Okay, you subtract it, just subtract and add the standard deviation twice. So if I were to ask you, if my average is 30 students per class, and I had 22 students, is that considered like rare, like holy cow? No, because 22 lives in here, right? What if I had 41 students?
Yes.
Yes, 41 is slightly above here. 45, just like I asked you above here, that was 45. 45? Yes, significant. Just the same conclusion as we had up here. So this, the 0.2% tells me yes, it's significant, and it's outside the other region, which also tells me significant. So those conclusions are in correspondence with each other, like they always are, right? They should be the same. Do we see how that works? Yes, yes? Okay, how do you know when to use the binomial versus the Poisson? Look at what you're given. Both of them are going to say the same thing. What's the probability of this scenario happening? Well, give me the information. Let's figure out what you're given. If you're given probabilities like P and Q, like percents of things, you're probably going to use binomial. If you're only given averages, you're going to use Poisson. Got it? Got it, got it? Okay. All right. The next thing, got it, got it?
Does that make sense?
This co-major is not a soft parent.
I'm not a soft parent at all.
Usually she beats.
I'm a yeller. Oh, I still have this filled in from, oh, wait a second.
Yeah,
Let me
we need some
go,
help.
nope, wrong.
BTA.
Let me go back to, I don't know. Ah. Do you guys have the review? Ugh. What a mess, what a mess, what a
But
mess.
we're not interested in it.
But you're not interested in doing it? Let me see your review, because I have the answers up here. Okay, really quick. Do
The Breaking Bad of a concrete.
That's not what I want. That's not what I want. That's not what I want.
The only answer
It's
I
probably
know
continuous.
is probably name. That's the only
Who?
question I can answer.
Ask.
Do I even give you any Poisson ones? How did that happen? 51% of the time. Oh, do number 13. That's it. On your review. Because that's Poisson. So do number 13. And that's it for homework. That's all. It says use the Poisson distribution to blah, blah, blah.
Are you still recording?
Do number 13. Yes. Yeah,
Oh,
I will.
have 5-1.
Oh, hey.
Why?
Perfect. Okay.